Hello everyone, today we're going to be solving some pretty simple quadratic equations. And so I want you to pause the video, try to do the problem yourself, unpause, and then watch the solution. Okay, so here we have a pretty good equation to work with, right? We don't really have to do anything special. All we have to do is find the two numbers, right? So what two numbers will multiply to give us 12 and add to give us 7, right? So we can try a couple different ones. So like, let's say, okay, 6, 2, that equals 12. I mean, 6 multiplied 2 is 12. 6 plus 2 is 8, right? That doesn't work. Okay, 3 times 4, that's 12. And that does give us 7. So these two are going to be the two numbers that we use. Okay, so we'll go x plus 3, because these are positives, x plus 4 equals. So now that's right. Now, we have to find basically what would x be to make us equal 0, right? Well, anything multiplied by 0 is 0, right? So these two are multiplying each other. And so all we have to ask ourselves, okay, what would we use x inside both of these to equal 0, right? So we're going to get two solutions. So right here we go, okay, what would we need for x plus 3 to equal 0? Well, x would need to equal negative 3. Okay, same thing with this one. What do we need for x plus 4 to equal 0? Okay, well, x would equal to negative 4, and that's our answer. Okay, now we have another question, another equation to solve. Kind of a similar concept, but just different numbers. So we're going to look for, okay, these two, right? So you ever heard you got A, a B, and you have C. So it's the same thing, right? Okay, negative 24 and negative 5. A little bit more tricky here, right? So you go, okay, since we know that this number is negative, right, and it's multiplication, it's not going to be two negative numbers, right? Because two negative numbers multiplying would give us a positive integer. So we know one is going to be. So we go, okay, let's start off simple. Okay, maybe 12 times negative 2. Yeah, that gives us negative 24. But when you add that together, that gives us 10, right? You can go, okay, maybe 8 times negative 3. Yeah, that gives us 24, but that gives us positive 5. Well, since we found positive 5, what if we just flip the signs, right? What if we go negative 8 times 3? Yeah, that gives us negative 5, and that gives us negative 24. So these would be our two numbers. And that's kind of a good trick you can use, even if you find, right, let's say it's negative 6, negative 7, and that's what you find, but it's positive is what you find. Just flip the signs, and you're going to end up getting your answer, like what you need, right? So we go over here, 8x minus 8, x plus 3, 0. And similar to before, right? What do we plug inside, right? What do we need x to be in order to make everything equal 0? Okay, well, let's look at the first one, right? X would need to be positive 8. Right here, right? X would need to be negative 3. And this is going to be our answer, right? These are our two solutions. Okay, so here we have another question. Again, pause the video, try to solve it yourself, and then unpause and see if you get the right answer. If you need help, you can always unpause as well and start seeing some of the steps. So this one's a little bit more trickier because now we don't have a perfect kind of setup to just do the problem, right? We have this 2 that's here in front of the x squared. But what we're going to do is we're going to take this 2 and multiply it here. Okay? And so now we're going to be looking for, obviously 15 times 2 is 30. What numbers give us 30 and 11? Okay. Well, okay, again, kind of just start off easy. You're just doing your 2, so you go 2 times 15. Yeah, that gives us 30, but that equals 17. That's not what we're looking for. 3 times 10, that gives us 30, but that's 13. There we go. Okay, 4 wouldn't work here, so we go to the next one. Okay, 5 times 6, that's 30, and 5 plus 6 is 11. So these would be our two numbers. But what's different here is because we have this 2 here, we're just going to split these two numbers in here. So our equation is going to be this. 2x 2, bad handwriting, plus 5x plus 6x, right, our two numbers, plus 15. Pretty terrible 15, have to do. So what do we do here? Well, simple. We just factor by grouping. So we'll do two little groups here. 2x2 plus 5x 6x plus. Okay. Now we go, okay, what can we factor out of each one, right? What's a common factor? Okay, well, this has an x, and that has two x's, so we can take one x out. Nothing really we can take out between the 5 and 2, so just an x, 2x plus 5. What about here? 15 doesn't have an x, so we can't, there's no common there for us to take out an x, but we can take out a 3, right? There's 2 3s and 6, and there's 5 3s and 15. So we can take a 3 out. Mind you, this is positive, so there's going to be a plus here. Okay, 2x plus 5. And so you see we have 2x plus 5. And so we can rewrite this to x plus 3 2x 5 equals 0. Right, because we have 2, we're going to combine these, basically combine the ones that we factor out and the ones that we have remaining. Okay, and it's a similar thing that we've been doing, right? Okay, well, what would we need to plug in for x for these to equal 0 on the inside? This one's pretty obvious, right? Okay, for this one, x equals negative 3. This one, we need to solve, right? So 2x plus 5 equals 0. Looking pretty easy, right? Subtract 5, subtract 5. 2x equals 5. Okay, divide by 2. And this would be the answer here. So our answers is negative 3 and negative 5 over 2. Okay, so here we have another question. Same thing. Pause the video, try working it out, and then unpause and see how I solve it. So this one, we don't have a 2, we have a 3. But one thing we notice here, what is something common that all these numbers have, right? 3, right? You can take a 3 out of 12, and you can take 3 out of 3. So we're going to just factor out a 3 to begin with, right? So 3, and then we'll just rewrite it. x2 minus 4x plus 4, 0. Right, and now we can solve this inside like we did for the first couple problems, right? Where we go, okay, well, what gives us positive 4 to multiply negative 4 when you add, right? 2 times 2 is 4, but 2 plus 2 is not negative 4, right? And because it's a positive integer, we know, well, it's probably going to be two negative numbers, right? If we have a negative here and we have a positive here, it's going to probably be two negative numbers that multiply to give us. So negative 2 times negative 2 gives us 4 and gives us negative 4 when we add them. So those are going to be our two numbers. So we'll rewrite this as 3 x minus 2 x 2, 0. these two are squared, right? These two are the same ones. So really, we can write it like this. 3 minus 2 squared, right, equals 0. And so now we go, okay, well, what do we need to solve this, right? Same thing. What would need to be inside here to make this 0, right? Just 2. Our answer is x equals 2. Okay, so this is going to be the last problem we're going to do. And for this one, we're going to use the quadratic formula. So this is a very important formula to remember. And part of the reason why is because it's basically like the silver magic bullet that can solve pretty much any quadratic equation. And especially it's important to remember if your professor, teacher, whatever, is not going to let you use a formula sheet or have this be able to written down or anything like that. You're going to probably get some questions on an exam that you can't really factor and you have to use the quadratic formula. So just for getting a question right, it's important. But also, you can use it on even the past problems that we've done. Even though you could factor them, you know, super easily, you could still just plug in the values. Now, you know, is that a good method to use? Probably not, because it's a lot longer. And knowing how to factor is an important skill, especially in upper level math. But you can just use the quadratic formula. And so it's very important to remember and know how to solve problems where you're going to use it, right? So if you don't remember the quadratic formula, it is minus b plus or minus b squared negative 4ac, and this is under square root 2 times a, right? And remember, when we're in this form here, this quadratic form, this is a, this is b, this is c. So all we have to do is just plug in the values, right? 3 plus or minus 3 squared all under square root minus 4, and I like to do a little bracket for the a and the c. So 2 times negative 7, and that's important to remember, right? Whatever sign is in front of this, the c, right? If this was a plus 7, we would have a positive 7 here, but because it's a minus 7, it's going to be negative, and that's a big deal because that can completely change your answer, right? Divided by 2 times 2. And so when we simplify, we go, okay, negative 3 plus or minus, and then under the square root we have 9, because 3 squared is just 9, right? 3 times 3 minus, and then this would be a negative 56, right? Because 2 times negative 7 is negative 14, then that times 4 gives us negative 56. And so because it's a 9 minus negative 56, right, we're going to get a, this is going to be equal to 65, right? And then under this, 2 times 2 is 4, right? So really, this is going to look like negative 3 plus or minus 65 divided by 4. But because there's a plus or minus, right, we're going to have two answers. So our answers are going to be x equals negative 3 plus square root 65 divided by 4. And the other answer is going to be negative 3 minus root 65 divided by 4. So, you know, not the best handwriting, but these would be our two solutions. These would be our two solutions. And you can see it's a very weird kind of answer. You know, you could kind of simplify it and see what, I guess, whole number it gives you. I'm assuming it's some kind of decimal. But that's how you would use the quadratic formula in these kinds of problems. And it's very important to remember this, right? Like I said, I think if anything, really all you have to do is just remember the formula, right? This up here, minus b plus or minus b squared minus 4ac divided by 2a. And then you're just plugging in values and simplifying. So I hope you enjoyed these problems. I hope you learned something from it and, you know, gave you more problems to practice and seeing them solve. And I hope you do well.